Welcome to aminacademy.com. In chemistry, we will discuss about quantum numbers. The set of numbers used to describe the position and energy of the electron in an atom are called quantum numbers. There are four quantum numbers, namely principal, azimuthal, magnetic, and spin quantum numbers. The values of the conserved quantities of a quantum number system are given by quantum numbers. The modern day model of an atom in which electrons are located in orbitals is also known as the quantum model. According to this model, electrons within an energy level are located in orbitals region of high probability for finding the particular electron. However, the model does not explain how the electrons move about the nucleus to create this region. To define the region in which the electrons can be found, scientists have assigned for four quantum numbers, that is principal, azimuthal, magnetic, and spin quantum numbers. The main energy level can be divided into sublevels. These sublevels are represented by angular momentum quantum numbers L, this here principal quantum number, angular momentum L, magnetic momentum M. That is angular momentum quantum number L. This quantum number indicates the shape or type of orbital that corresponds to a particular sublevels. Here, the chemists use a letter code for this quantum number. A quantum number L equal to 0 corresponds to an s orbital, that is L equal to 1 to p. Then p orbital L equal to 2 is d orbital, L equal to 3 to an f orbital. For example, an orbital with n equal to 3 and L equal to 1 is called 3p orbital, and an electron occupying that orbital is called 3p electron. Next, magnetic quantum numbers. They symbolized by M. Magnetic quantum number is symbolized by M, is a subset of L quantum numbers. It also indicates the number and orientation of orbitals around the nucleus. The value of M takes whole number values depending on the value of L. The number of orbitals include 1 s orbital, 3 p orbitals, 5 d orbitals, and 7 f orbitals. Next, spin quantum number. The spin quantum numbers symbolized by positive half to negative half, that is upper arrow to downside arrow, indicates the orientation of an electron's magnetic field relative to an outside magnetic field. A single orbital can hold a maximum of 2 electrons, which must have opposite spins. Now, next we will discuss about electron configuration. Regarding that, some rules we will define. First, Pauli's exclusion principle. The Pauli's exclusion principle is the quantum mechanical principle which states that two or more identical fermions, that is particles with half integer spin, cannot occupy the same quantum state within a quantum system simultaneously. Next, Aufbau principle. Aufbau principle states that in ground state of an ion, electrons fill atomic orbitals of lowest available energy levels before occupying higher level. That means first the electrons is filled in lowest available energy, then one by one it goes upper, that is higher levels. This means that the orbital with lower energy will be filled first, followed by the orbital of high energy. Next one, Hertz rule. Every orbital in a subshell is slightly occupied with one electron before any one orbital is doubly occupied, and all electrons in singly occupied orbitals have the same spin. Next, here look at this. For electronic configuration, we have to follow this rule. First we have to write 1s2, 2s2, 3s2, like after that 2p6, 3p6, 4p6, and this order 3d10, 4d10, like then like we have to continue f, that is 4f14, 4f14, like here. After that you have to cross this line. This first 1s2, second is 2s2, third line is 2p6, 3s2, like you have to go this cross way. Now here look, here 1s is lesser than 2s and lesser than 2p, lesser than 3s, lesser than 3p, like it continues. Here we'll, for example, we'll take, suppose atomic number, the element of atomic number 20 is, here we have to write this order 1s2, 2s2, 2p6, here 1s2, 2s2, 2p6, 3s2, 4s2, 1s2, 2s2, 2p6, 3s2. Here we will count the electrons, that is here, these are the electron numbers, that is 2 plus 2 plus 6 plus 2, that is 2 plus 2 plus 6 plus 2. Then further we have to do, because we need more electrons to be occupied, 3s2, then 3p6, 4s2, like here up to 3p6, 4s2. Then we will count the number of electrons, 2 plus 2 plus 6 plus 2 plus 6 plus 2, these numbers, like 2 plus 2 plus 6 plus 2 plus 6 plus 2. Here 4, 6, 10, 12 and 20. Totally here it will 20. That means this here up to, that is 3, up to 1s2, 2s2, 2p6, 3s2, 3p6. We can do this as organ, element organ, and 4s2. This is the way to represent electronic configuration of an element, the given element. For the detail we will continue next videos. We have done. Please subscribe our YouTube channel.